Hello, math students. I wanted to take this opportunity to welcome you to the online version of Mr. Hargrove's 7th grade math class, where today we will be discussing how to solve two-step inequalities. The learning target for this lesson is as follows. Today, I will solve two-step inequalities using zero pairing and grouping. That should sound familiar to you. And the success criteria is as follows. I can identify the following symbols. I can solve for x when it is not set equal to another term or number. And I can determine values that make the inequality true. These are all things that we will be doing in today's lesson. For solving inequalities, you should be reminded that it is very much like how you solved equations. However, with inequalities, you must remember a few things, and they're listed here. Always move the variable to the left of your sign before solving. That isn't something that is 100% mandatory. However, when you're first learning inequalities, you'll find that they're a lot easier to solve when the variable is on the left. It didn't really matter with equations. You can have it on either side, but for inequalities, we want it on the left side. Then you must remember to flip the sign the opposite direction. So whenever you move the variable over to the left, if it's not already there, you do have to make sure that the sign flips as well. And you're going to see we're going to cover an example like that. And also, you always flip the sign whenever you multiply or divide both sides by a negative number. We're going to get into the examples. That I know that may sound like a lot, but just know we're going to get into the examples. And the cool thing about this being a video is that you can pause, replay, fast forward as needed, so you have that freedom and flexibility as well. This is a good time to pause the video to make sure that your notes that are in front of you look like this. You have notes that have this filled in, but this area is blank. You're going to want to fill this in. So good opportunity, time to pause the video. When we deal with the less than sign, that's obviously what it looks like. This is what it looks like whenever we graph the inequality. We always want to graph our inequalities, and you need to know that if it's less than, it is an open dot, and a good way to remember which direction the arrow points is just look at the sign. And if you look at the sign, you can place a little arrow there, and that lets you know that when it's time to graph my solution, my arrow should go that direction. So for your benefit, I have it here. This is how to graph our inequality solutions. This is the less than or equal to. It's closed dot because that means that my solution can also be that number, but it can also be any number that's less than that number. And again, you can look at which way your arrow is pointing by looking at the symbol. Greater than is an open dot. That means it cannot be that number. It must be greater than that number. So it would be an open dot going this direction. Again, look at the direction that it's pointing. Greater than or equal to, closed dot, because it can be that number or any number greater. The most difficult thing that a lot of 7th graders encounter when they're dealing with inequalities is they're very similar to equations and how you solve them. However, with equations, you only had one answer. Only one answer works. If x equals 1, then the only thing that x can equal is 1. That's not the case with inequalities. With inequalities, there is more than one solution. If you say x is less than 4, then that means x can be any number that is less than 4. If it's less than or equal to 4, it can be 4 or any number that's less than 4. A lot of times 7th graders get hung up on that, the fact that there is not just one answer. But just know that in this unit right here, you're not going to use the equal sign. These are the 4 signs that you're going to use, and you need to make sure you familiarize yourself with them. Another couple of notes. The variable, again, should be on the left side to graph the inequality. not 100% mandatory as you move into your higher level maths, but since this is the intro to inequalities, it's something that we want to do as a best practice while we're learning inequalities. You also, as I already mentioned, use the sign as an arrow to point the direction that your arrow should go. Covered that in the previous slide, but for emphasis sake, we put it here also. So now it's time to dive into some examples. And again, as I go through these examples, feel free to pause the video as needed. But let's look at the first example. It says that 3x plus 4 is greater than, you notice it's opened up to here, so that means that this is greater than or equal to 16. The first step in solving this inequality, it's the same first step as you dealt with equations. I'm going to put a box around my variable. The reason that I'm doing that is because that is a note to myself that I am not going to do anything with that number at this point. I need to zero pair first. However, I am going to get to a point when I need to divide. That's the number that I'm going to divide both sides by. That's why we put a box around it. We then want to subtract 4 on both sides to get a zero pair. Since that says plus 4, I'm going to subtract 4. I am then going to draw this line and I'm going to bring down what is left, which is 3x. A lot of students forget to do this. Bring your sign down also. 3x is greater than or equal to 16 minus 4 is 12. At this point, this is what I have. And in order to get a solution, I now need to divide both sides by whatever number is next to x. The number that I put in the box there, which is 3. I'm going to ask myself, what's 12 divided by 3? And that's going to give me x is greater than or equal to 4. So this is the solution to the inequality. Now I need to graph the solution. And to graph it, this is what you do. Just make a number line. Give me a couple of numbers around 4. We'll go 3, 4, and 5. Now remember your previous slide. If it says greater than or equal to, then that means that it's going to be a closed dot on the 4. In which direction is the arrow going to point? Well, you look at which direction is your inequality symbol pointing, and it's pointing this direction. So this is clearly saying that x can be any number that is greater than or equal to 4. So therefore, x can be 5, x can be 6, x can be 1,000, because all the numbers that I just mentioned are greater than or equal to 4. X can be 4. X cannot be 3, because 3 does not fall within the solution set. X cannot be 1. So these are all things that you just have to make sure you familiarize yourself with, but that's just the first example. I'm going to erase this and we'll move on to example 2. Example 2 reads as such: 7 minus 4x is less than negative 1. The first thing that I'm going to do is I'm going to put a box around my variable and also that minus sign that is in front of it. Remember, we treat a minus sign like a negative sign because they function the exact same way. After that, now I have to zero pair. So whatever is outside of your box that is on the same side as the inequality symbol, you need to get rid of, and that number is 7. So how do you get rid of positive 7? Well, you zero pair it with minus 7, negative 7. So now that's 0. I'm going to bring down what is left, which is negative 4. X is less than Negative 1 minus 7 is negative 8. Now we're at that critical point because this is a problem where you will divide both sides by a negative number. And I know I'm going to divide both sides by a negative number because the number next to x is negative. So when I do that, remember, your sign is going to flip. It is just a rule that you have to get used to. So we're going to practice it. I'm going to divide both sides by negative 4. When I do, my sign is going to change from its current direction to this direction. It automatically flips whenever you divide both sides by a negative. And my solution will be x is greater than negative 8 divided by negative 4. Well, a negative divided by a negative is a positive 2. So this is the solution. X is greater than 2. And we can come over here and graph that. We'll just say that that's 1, that's 2, that's 3. I'm looking at a closed dot, open dot, on the 2. Clear some space in here. In which direction is the arrow going to go? Well, if you look at the symbol, it tells you. So this solution is saying that x must be greater than 2. So again, can x be 2? No. It has to be greater. That's why we have an open dot. Can x be 3? Yes. Can it be 4? Yes. Can it be 1 million? Yes. It can be any number that is greater than 2. Can x be 1? No. Can it be 0? No. Has to be any number that is greater than 2. Now I'm going to erase this and we will look at our final example together, and that is going to be example 3. Now what you should notice first about example 3, where is your variable? It's on the right side, and if you look at your notes and remember what we said on a previous slide, when you're dealing with inequalities, you don't want the variable on the right, you want it on the left. And you're going to see why. It's easier to solve and get a solution when it is on the left. So, what I've seen students do that's proven to be helpful for them is this. Instead of rewriting the whole thing, they just use this 2x minus 5, and they remember that when you move the variable to the left, you also have to flip the inequality sign. Again, that's another stumbling block for 7th grade students, as they forget that. Whenever you multiply or divide both sides by a negative number, your sign flips. And also, whenever you move your variable to the left, your sign flips. Those are the 2 reasons that your sign will flip. But this is what I've seen students do. They go ahead and they flip the sign around, and then they just put the negative 9 here, and then they cross this out. That works. Or if you just want to rewrite it, you can. But this is a little less work for you. Now you just follow your steps of solving it. So, what we're going to do here, I'm going to put a box around my variable and the x. My variable, and the number next to it. I then need to 0 pair this minus 5. So how do you 0 pair minus 5? Well, you have to add 5. Whatever you do on one side, you have to do to the other. Draw this line. I'm going to bring down what is left, which is 2x is greater than or equal to negative 9 plus 5, another obstacle for some 7th graders. But ask yourself, well, which number has more? Are there more negatives or more positives? There are more negatives, so I know my answer is going to be negative. And then you just do 9 minus 5, which gives you 4. So your answer over here is negative 4. You then need to divide both sides by 2. I still get some 7th graders, though, that say, wait a minute, Mr. Hargrove, isn't your sign going to flip because there's a negative number over here? No. It only flips when you divide or multiply both sides by a negative number, or when you have to move your variable over to the left. Not just because there's a negative number right here, the sign is not gonna flip. So, it's gonna remain the same. X is greater than or equal to a negative divided by a positive is gonna give you a negative. So, X is greater than or equal to -2. I'm now gonna graph that solution. We'll just say this is -3, -2, -1. It says greater than or equal to, so I'm going to be a closed dot. That closed dot means that X can be -2 or any number that is greater. So, since -1 is greater than -2, X can be -1. X can be 0, X can be 10, X can be 1,000,000, okay? But X cannot be any number that is less than -2, so it cannot be -3, it cannot be any other number going that direction. So, this is how you solve basic inequalities. So, this is what I want you to review and be able to do. And at this time, we're going to get some more practice on this. So thank you for your attention.